Hello Hochil, so today is the third lesson on probability. So today we're going to be calculating probability for independent and dependent events using tree diagrams. So some of the keywords you may see today are outcome, independent, replacement and probability. Again, let's recall what probability is. Probability is equals to the desired outcomes divided by the total outcomes. It's how likely an event is going to occur. So the real life link in this is business, banking, marketing and data analysis. So they use these data trees to create data for insurance companies and for banking, for mortgages and insurance risk. So here's our question. Rebecca has 9 colored beads in a bag. 4 of the beads are black and the rest are green. She removes a bead at random from the bag and notes the color before replacing it. That means she's going to put it back. She then chooses a second bead. So from this we're going to draw a tree diagram showing all the possible outcomes. So here's our first choice. We have black and we have green. So it says in the question, I'm just going to underline some key information. 9 colored beads in our bag, so we have 9 in total, and 4 of the beads are black. 4 of the beads are black and the rest are green. The rest are green. So 4 are black and we have 9 beads in total. 4 out of 9 are going to be black. So the remaining, that means we have 5 remaining. It's going to be 5 out of 9 that are green. So this is our first choice. So now we're going to branch out in our tree diagram. We have a second choice. So again, the two options are black and green. And from the question, it says that it's being replaced. So it's not being kept out of the bag. So again, it's still going to be 4 out of 9 and 5 out of 9. And that too on the second branch. So what are our outcomes? We have the probability of getting 2 blacks. We have the probability of getting a black and a green. We have the probability of getting a green and a black, and then we have the probability of getting 2 greens. So the probability of getting a black and a black from this independent probability is going to be 4 over 9 times by 4 over 9. So some of you may be wondering how we got that 4 over 9 times by 4 over 9. So if we're going to get 2 blacks, let's follow the tree diagram. We're going to get a black here, so we're going to have 4 over 9. And we're going to get another black here, which is also 4 over 9. Okay, in probability, when we say and, that means times, yeah? So this and means times. So we're going to take this probability 4 over 9 and we're going to times it by this probability of 4 over 9. So let's see if we can apply that to the next one, the probability of getting a black and a green. So let's follow our tree diagram. I'm just going to erase these here. Let's follow our tree diagram. A black and a green, so we're going to go black and then we're going to go green. So these 2 probabilities here. So again, have a look on the right hand side. We are using the term and, so we're going to multiply these 2. So it's 4 over 9 times it by 5 over 9, and that is equals to 20 over 81. Okay, probability of getting a green and a black. So I'm just going to erase that here. So if we're going to get a green first, we're going to go here. So we're going to have this one. That's our probability. And then we're going to get a black. That is our next probability. Again, we are using the term and. So we're going to multiply these 2 probabilities. So 5 over 9 times by 4 over 9, that will be equals to 20 over 81. Okay, and last but not least, we are going to have a green, and then we're going to have another green. So our 2 probabilities are 5 over 9. Don't forget, again, we have used the term and, so we're going to multiply these 2 probabilities. So 5 divided by 9 times by 5 divided by 9 equals to 25 divided by 81. So on the right hand side, you should see these are all of our probabilities here. These are all our probabilities of the outcomes. So the probability of getting 2 blacks is 16 over 81. That's this one here. The probability of getting a black and a green is 20 over 81. Probability of getting a green and a black is 20 over 81, and the probability of getting 2 greens is 25 over 81. Okay, again we have the same example, but we have a sub question now with asking us to calculate or write down the specific probabilities. Okay, so if we have a look at B, what is the probability of getting 2 green beads? Probability of green and green, that is equals to 25 over 81. And what is the probability of getting a black followed by a green? Black and green, that is equals to, the black and green is 20 over 81. So those are our probabilities. I would like you to pause the video and have a go at copying and completing this tree diagram and finding the probabilities. Once you're finished, resume the video. Okay, welcome back. So the probability of Matt scoring is 0.6. He's taking a penalty and the probability of him scoring is 0.6. So guys, remember, total probability adds up to 1. So 1 take away 0.6 will leave us with 0.4. So the probability of him missing is 0.4. Again, same with Thomas. If the probability of him scoring is 0.7 and total probability adds up to 1, the probability of him missing is 0.3. Yeah, that's just to let you know where the 0.4 and the 0.3 has come from. Okay, let's calculate the probabilities that are missing on the tree diagram. So the probability of Matt scoring and then Thomas missing, remember and means times, it would be 0.6 times 0.3 equals 0.18. Yep, 0.18. Just going to fill the rest of these in. And the probability of Matt missing and then Thomas scoring is 0.4 times 0.7, which gives us 0.28. And finally, the probability of Matt missing, which is 0.4, times by the probability of Thomas missing, which is 0.3. 0.4 times 0.3 is 0.12. Okay, so find the probability of both boys missing. So the probability of both boys missing is this one here, where they both miss, is 0.12. The probability of one boy scoring, if one boy scores, that means either Matt scores or Thomas scores. So it will be these two probabilities added together, and that will give us 0.46. Find the probability of at least one boy missing. So that means at least one of them miss, or both of them miss. So we're going to add up these three. I'm just going to show you here. We are going to add up these three here. The reason we add these three is because either Thomas has missed, or Matt has missed, or they have both missed. Yeah. So 0.28 and 0.18 and 0.12 should give us 0.58. So it's 0.58. Okay, we have come on to the main task. So if you are in set 5, I would like you to do all of red and all of amber. And if you are set 4, I would like you to do all of red, all of amber, and on the next slide that I'll put up at the end where you can pause the video, I would like you to do all of green. So this is the independent task where we have green for the people who in set 4 are going to complete as well. Once you have finished, please upload a picture of your solutions onto ClassCharts. And if you have any questions, please message a member of staff, and good luck.